This is Qwen Image, a state-of-the-art open-weight image generation model running locally on the new framework desktop, powered by AMD Ryzen AI Max, also known as Strix Halo. And this is WAN 2.0, another new state-of-the-art model, but for video generation. To give you an idea of what's possible with these models, here are some examples. In this generation, you see a wall with graffiti where the model manages to render detailed text very clearly. And here you see a photo of the framework desktop edited to remove a lamp and place the framework right at the center of the table. And here's a picture of me where the color of the t-shirt has been changed to black, and one where I've been transformed into a Ghibli-style character. And here is a video generated from a still picture of the framework desktop where the camera rotates around it to show a different side. It's quite impressive, the level of detail that it can achieve. But before we get too excited, I want to set some expectations. Running these models on Strix Halo is possible and it works, but right now it takes a lot of patience because performance is quite limited and the support for Strix Halo in the AMD software stack is still at a release candidate stage, not optimized for performance and quite unstable. Generations can run anywhere from 5 minutes to hours, and you might see the GPU crash occasionally, meaning you have to start all over again. In my last video, I ran LLMs on an HP Mini with the same AMD chip. The response from you was incredible, and that gave me the motivation to keep going with this series. Off the back of that video, Framework even got in touch with me and sent me one of their pre-production units so I could keep experimenting on Strix Halo. And that's what I've been doing for the past few weeks. The version they sent me comes with 128 gigabytes of RAM and 1 terabyte of disk space. The build quality is solid, as you'd expect from Framework. The cooling is excellent and it stays almost silent even under heavy load. They've also added a front panel with tiles that you can swap out. It's a nice touch and I absolutely love it. I've already 3D printed a few custom tiles for it, and I will leave the STL files in the description if you want to print them yourselves. Now, here's the plan for this video. As I value your time, I'll start with a TLDR for those who want to get running right away. After that, we'll dive a little bit deeper into the toolbox that I provide with look at Qwen Image Studio, and then I'll show you how you can use ComfyUI and generate videos with WAN 2.2. Finally, I'll spend a few minutes explaining how these models actually work. As we did on the HP Mini in the other video, go into the BIOS of the framework and set the GPU VRAM allocation to 512 megabytes. Then add these kernel parameters to allow the GPU to use all of the available system memory. Next, pull my pre-configured toolbox. It has ROCm 7, the AMD version of CUDA to access the GPU, Qwen Image Studio, ComfyUI, and WAN 2.2 already set up. Now, this is a very large sandbox, over 30 gigabytes, so it'll take some time to download. Once downloaded, you can enter it with the following command using the toolbox CLI. If you haven't used Toolbox before, this is just a container system based on Podman. You can basically create a seamless Linux environment that feels like a normal shell. You'll be using the same system user that you use on your host and have the same home directory. So all the weights that we will download and images and video that we generate will stay in your home directory on the host outside of the container. Now, this means that you can delete or refresh the toolbox without losing any models or any generations that you've done. To use Qwen Image Studio, you'll first need to download the model weights, and you can do it with the following command. You'll see different options, and for now let's just get the image generation model and the LoRa adapters for running faster generations. I'll explain more about this later. Be mindful that these models are large, more than 40 gigabytes, so be patient. Once you have the weights, you can just start Qwen Image Studio. That gives you the web UI on port 8000. Now, if you're running these on a server and have an SSH shell as I do, ensure to forward the port locally with this SSH command. Open localhost 8000 in your browser and you see tabs for generating and editing images. Simply type a prompt and select, in this case, ultra fast for your first generation. This should take around 3 minutes, and here is your first image. Now that we generated our first image, let's take a closer look at the model itself. Qwen Image comes into two main variants: Qwen Image for generation and Qwen Image Edit for editing. Each base model is about 40 gigabytes. You can check their capabilities on Hugging Face. They have many examples for what these models can do. On top of the base models, there are LoRa adapters for fine-tuned versions. LoRa stands for low rank adaptation. Instead of retraining an entire model, with LoRa you can freeze the original weights and only train a small set of additional weights that are called adapters. Now, these adapters are compact, just a few gigabytes, and they can be applied on top of the base model to adjust its behaviors. For Qwen, there are LoRa adapters called Qwen Image Lightening. These are fine-tuned adapters that specifically teach the model to denoise in fewer steps. Normally, the base model should be run at 50 steps. Now, with Lightening 8-step or 4-step adapters, you can get good generations in a fraction of the time, around 5 to 16 minutes on Strix Halo for the 8-step version, and even faster with the 4 steps. Quality can be lower than the full model, but for many types of generations, it is actually quite good. So, when you are in the toolbox and running Qwen Image Studio, you can choose between the full base model, which requires, as I said, between 20 and 50 steps to generate good images. You can choose the 8-step fast adapter or the 4-step ultra fast adapter. We already saw how to generate our first image, so let's also try out the editing workflow. Click on the Edit tab, pick any input image and set an editing prompt. In my case, I used a picture of myself and asked the model to convert it into anime style and add custom text on the t-shirt. For this demo, I am selecting again ultra fast. Keep in mind that these fast Lightning LoRa adapters tend to work better with simpler or more generic compositions, things like anime or cartoon style, or broad, colorful scenes with strong structure, for example, a neon-lit Hong Kong street full of glowing signs, often come out quite well. For more detailed and nuanced photorealistic edits, they can be hit and miss, so you may need to experiment and move to the full models. If you look at the command line, you can actually see the underlying command that Qwen Image Studio runs using my modified version of Qwen Image NPS. If you like, you can use the CLI tool directly from the sandbox and skip the web UI. Just ensure that you run it from within opt Qwen Image Studio directly. As I said earlier, the main problem right now is that ROCm is still quite limited on Strix Halo. Performance is slow and stability isn't there yet. The current 7.0.0 release candidate will very often crash the GPU with page faults. These are known problems, and you can track their development on this GitLab issue. According to AMD engineers, some patches have already been developed, but they have not been merged yet into the release candidate for ROCm 7.0.0. At the moment, there seems to be a plan to include these patches into the next minor release, which is not great as it might take months. But I invite you to add a comment to this GitLab thread to see if we can maybe get more attention and get the stability patches merged as soon as possible. The good news is that Qwen Image Studio has a built-in retry policy up to 3 times per job, and in my experience, a single retry has always been enough. After Qwen Image Studio, the other option to generate images is ComfyUI, and it's already in the toolbox. ComfyUI gives you a node-based interface where you can design your own pipelines. It's very versatile, but it can also feel quite intimidating and complex at the beginning. That's one of the reasons why I built Qwen Image Studio. It's a simpler way to get started and it handles crashes more gracefully. Still, if you enjoy building your own graphs and want maximum flexibility, ComfyUI is definitely worth considering. One of the advantages of running Qwen Image in ComfyUI is that you can use the FP8 scaled weights, specifically the FP8 E4M3FN variants. That was a mouthful. FP8 here refers to an 8-bit floating point format. Because it's only 8 bits per value instead of 16, the model takes up about half the memory and runs more efficiently without losing too much precision. On Strix Halo, this makes a clear difference in speed and memory footprint. For example, it takes around 16 minutes to generate an image with 20 steps versus 1 hour that would take with the full model. Now, to get started, the first time you run the sandbox, you need to tell ComfyUI to load model weights from your home directory, and this can be set up by running the set extra paths script under /opt. You only need to run this once and it will create a directory called config models in your home directory and drop an XML configuration file into ComfyUI directory so that it knows to read files from your home directory. Next, you need to get the model weights. You can do this by using the get Qwen image script. Again, these are different than the weights you downloaded for Qwen Image Studio. They are in this FP8 format. Then launch ComfyUI from the toolbox with the following command. This also runs the web UI on port 8000, so you can connect through the same SSH port forward that you were using for Qwen Image Studio. Now, to generate your first image, you can navigate to the ComfyUI example website for Qwen Image, download the sample image and simply drop it into the UI. Now, these images embed the workflows in their metadata, so ComfyUI can load the workflow just by looking at the image. So now you can edit the prompt and the number of steps if you want, and generate an image. With these settings, it will take around 16 minutes on Strix Halo.
A few minutes later.
Editing works very similarly. Just drag and drop the sample image provided in the ComfyUI examples, upload the image you want to edit, provide the editing prompt, and off you go. Now, the way I've configured ComfyUI in the toolbox, all your output images or videos will end up in your home directory outside of the toolbox in a directory called Comfy Outputs. The toolbox also includes WAN 2.2, which is Alibaba's open text-to-video and image-to-video model. Right now, you can run it from the CLI or inside ComfyUI. I'm also building a separate web UI called WAN Video Studio, which is the same idea as Qwen Image Studio, but for video generation. It should make things much easier to run and more reliable than ComfyUI. If that's something you'd like to see, I'll cover it in my next video. For now, to generate a video, change into the opt1 Video Studio directory. Again, there is no real Video Studio web UI yet. So far, this is just a slightly modified version of the official CLI tool provided by Alibaba for WAN 2.0. First off, you'll need to download the weights. These are a mixture of expert models, and there are three versions. A model with 14 billion active parameters for text to video, one for image to video, and a smaller model with only 5 billion active parameters that can be used both for text to video and image to video. We'll use Hugging Face CLI to download this last model to our home directory under the WAN 2.2 TI2V 5B directory. Then, to generate a video, we can use this command that you can find in the README of the AMD Strix Halo image video repository. The important parameters here are the prompt, of course, the number of frames to generate, and where to save the file. I suggest, as usual, that you save your files outside of the toolbox in your home directory. In terms of frames, they need to be a multiple of 4 plus 1. 121 frames is the recommended value for a 5-second generation, and this will take between 4 to 5 hours. And I know, it's a lot, but video generation is really hard, and it's incredible that it is even possible on such a consumer CPU without a dedicated GPU to be able to generate any video at all. If you want to generate a video from an image, simply add the source image with the --image parameter. So far, I haven't been able to get good quality outputs from the 5 billion parameter model, and I've seen others online reporting the same. The larger 14 billion models do run, but a lot slower. The more promising path is the set of Lightening LoRA adapters, similar to the ones for Qwen Image, that can bring generation down to just 4 steps. Now, that's a huge improvement in speed. I'll be experimenting with those in the next few days, and I plan to integrate them in WAN Video Studio as soon as I release it. And I'll probably cover the results in my next video. So this is Donato from the future with a cold editing this video. But I have good news. As I said, I've been experimenting with the Lightning models, and they do work quite well on the Strix Halo. So here I've updated the instructions in the README to show you all the commands you need to download the weights and to generate the videos. And now I'm going to show you a couple of examples of what is possible. This is a video I generated in 30 minutes from a prompt. And this other one took 40 minutes from an image. You do need to pick a lower resolution, but the good news is that they do work and they're not that bad. But again, I will be working on a UI for these, and I'll try to see if we can get better performances as well. Now, you will have certainly noticed that instead of just downloading one model, as we do for LLMs, for image and video generation, we need multiple models. Indeed, image and video generation is a much more complex process and is based on something called diffusion. If you want to understand more about what's going on under the hood, I recommend watching the excellent 3 Blue 1 Brown video on diffusion, as well as Julia Turk's video on the same topic. I leave the links in the description. But if you just want a quick TLDR, here's what's happening with the different models in the pipeline. First, we need a model to encode the input prompt. If you watched my video on multimodal LLMs, there's a section describing the clip model. This can turn text into a vector representation or embedding that captures its underlying meaning. Qwen Image uses Qwen 2.5 VL as an embedding model, which is trained on pairs of text and image data. Next, we have the diffusion model, the generator. Qwen Image uses a multimodal diffusion transformer. It works by starting from random noise in the latent space and iteratively denoising it step by step until the structure of the image emerges. Normally you run 50 steps, and each step only makes a small correction. The Lightening LoRA adapters modify this process. They add extra trainable parameters on top of the base model, and these parameters have been trained so that the model can reach a good result in just 8 or even 4 steps. And that's why they are much faster. The base model is totally unchanged, but the adapters steer the denoising process to converge in fewer iterations. The variational autoencoder is the bridge from the latent space back to actual pixels for image generation. After denoising completes, the decoder converts the final latent tensor into an RGB image at the target resolution. Generating in latent space keeps memory and computation manageable while still recovering full resolution images at the end. Thanks again for the response to the last video. The support and feedback really motivated me to keep working on these ready-to-use toolboxes for Strix Halo. First for the LLMs and now for image and video generation. It's been great to see a community forming around this new AMD hardware. And if you want to experiment together and have questions, why not join the Discord? The link is in the description. And don't forget to comment and like if you found this useful. Coming up, I'll be working on Qwen Image Studio, and hopefully I will find a way to make video generation actually usable on the Strix Halo chip. I will be also publishing more LLM benchmarks and explanations of the different ROCm configurations such as HeapBlast LT and ROCWMMA and how they perform on Strix Halo. I've been using the framework desktop to benchmark all of these different configurations, and you can see the current results on some of the most used open source models. I'll leave a link to the benchmarks in the description. I'm also planning a video on training and fine-tuning LLMs locally on the Strix Halo. So stay tuned and subscribe if you want to follow along and get the best out of your new Strix Halo chip.